Welcome back, folks. It's Mr. Vass here, and we have a special lesson for you called Section 3.6C, and the C stands for calculator. I'm going to walk you through the things you should know how to do on your calculator. I've been warning you that this time was coming. There are things you need to know how to do on your calculator, and today's the day where we look at those and make sure you know how to do them. Okay, so the first thing we're going to do is try to store a function in memory. Jump ahead and boom, look, here's the calculator. This should look very familiar to you. It's the calculator that you all have on loan from me. So the first thing I'm going to do is type in f of x. And now to store a function in memory, I need a very special equal sign. It's this guy right here. It is a colon followed by an equal sign. Now just type in the function. Grip it and rip it. Boom, we're done. Function is stored in memory. Let's see what we have to do next. Evaluate a function. Find f of 3. Okay, so we're asked to find the output of the function when the input is 3. It's this simple, folks. Boom. It's -5. So there's a point 3 comma -5 on the graph of f. We are cooking with gas, people. Okay, step 3. Take the first and second derivatives of the function with a bright, bold, and italicized cast warning. I know that you can do the power rule here and evaluate f prime of x as 3x squared minus 4x minus 5, or f double prime, power rule again, as 6x minus 4. I know that you can do that, people. Okay, but I just want to show you that your calculator can do it as well. Okay, so let's jump over to the calculator, and here's why it's called a computer algebra system, CAS, right? Because it can do math, it can do algebra. Even calculus. So we're going to ask it for the first derivative with respect to x of f. Grip it and rip it. OMG, the calculator knows the power rule too. Well, better than some of you, I think. Okay, so we got 3x squared minus 4x minus 5. That matches up with what we thought the first derivative was. Let's see if it can do the second derivative just as easily. Oh, look at that. Leibniz notation for the second derivative. How about that? Grip it and rip it. Boom, 6x minus 4. So we did both of those things, and now it's time for the CAS warning. You will never be asked a question on the AP exam where that feature is an advantage to you because you have a CAS calculator. Because somebody using a TI-84 graphing calculator may not be able, that doesn't have a computer algebra system in it. So it's not going to symbolically find derivatives for you. Okay, so just know that with great power comes great responsibility. The CAS calculator has a whole lot of power to it. Don't use it as a crutch. If you use it as a crutch, you know something else is going to get weaker, and that is going to be your skills in calculus. Okay, step 4 here says store the first and second derivatives of a function in memory. We already know how to store a function in memory, so this is really just kind of, if I ever needed to use this derivative and evaluate it, I could store that in memory. Maybe I call it fp of x for f prime. Got to use the special equal sign again. And then I'm just going to go up and grab that function. Boom. Done. There's fp of x, right? Let's say I want to do the second derivative, fpp of x. Okay. I could just ask the calculator to take the second derivative here of f and store that in memory to fpp of x. Boom. It says done. Let's double check. What is fpp of x? How many times have I said pp? It starting to sound a little weird. So yeah, calculator did that. That's great. Let's look back and see what we got to do next. Okay. Oh, this one is important. It says evaluate the derivative at a point. Okay, so I've already stored my derivative in memory. I could just do f prime of 3, but I want to show you what finding the derivative or evaluating the derivative at a point means. This is something you're going to, you should know how to do on the calculator. I'm going to go ahead and clear some screen here just so we have a nice clean white space here. So to find the derivative f prime of 3, I could just type fp of 3, grip it and rip it, because I stored that derivative to memory. But let me show you another way, okay? Menu. Oh boy, look at option 4. That's this whole class, calculus. Would you take a look at that? Option 2 is derivative of a point. So let's see what happens if we select that. It gives us a little template here to enter some things. The variable we're working with is x. The value we are interested in is 3, and we want to use the first derivative. I hit enter, and it has that derivative symbol, and then the such that symbol, x equals 3. So now I'm just going to type in f of x here and evaluate the derivative of f, the first derivative of f at x equals 3, and it's 10. Wow, that's pretty amazing. Okay. You can also just type this stuff in because the such that symbol is available to you. And let me show you what I mean. First derivative with respect to x of f such that, wait for it, such that x equals 3. Look at that. 3 different ways. There's more than one way to skin a cat, folks. I just showed you 3 different ways to evaluate the derivative of the point. I'm going to encourage you to remember this one. Okay, let's jump back over here. Oh, now we're going to use the solve command. Some of you guys love this guy. So we're going to solve this equation. F of x is equal to sine x. So let's see what happens when we run the solve command. Clear the screen. Boom. Menu. 3, 1. Solve. F of x, that's that cubic function we've been working with, is equal to trig function, sine x. You'll notice here that I'm in radian mode. You better stay in radian modes. If you switch this thing radian mode, if you switch to degrees, it's going to be wrong, right? It's going to be wrong unless the problem specifies degrees. So there's the equation I want to solve. And now I need to tell the calculator what I want to solve for. I would like it to solve for x. Grip it and rip it. Boom. Hey, look at that. I got some nice approximate values there. There's one at negative 1.68074, another one at 0.159019, and then another one at 3.37389. There's a little warning here. Let's see what it says. Click on it. It says more solutions may exist. Try specifying appropriate lower and upper bounds, yada, yada, yada. Okay, I don't know if that's important or not. Boy, if I was doing this in a question on the AP exam, I'd want to make sure I checked that to see if it was if there were any other solutions I needed. And I will show you how to do that in a moment. Okay. So let's jump into back over here. So we did this one. Okay. But notice this next one. It says solve f of x equals tangent of x, but it's given me this domain restriction here. And that's really important with trig functions when you're using the solve command, because as you know, trig functions repeat. And it's possible that there are an infinite number of solutions to f of x equals tan x. So let's go ahead and take a look at what happens when we restrict the domain. And I'll actually do it 2 different ways for you. First thing I'll do, menu 3, 1, I'm going to solve f of x equals tan x. Specify that I'd like it to solve for x. So I'm not going to restrict the domain. And what you're going to see here, oh, that's not too bad. Okay, but look, there's more answers over here. That's what that arrow means. Holy smokes, when does it end, right? Okay, this is already giving me a headache. So let's jump back up here. Grab the solve command again, and now restrict the domain. Okay, so I'm going to restrict the interval where it looks for answers from negative pi over 2, positive pi over 2. Let's see what happens. Oh, would you look at that? There's only one answer we need to be concerned about. We didn't even see that when we were scrolling across this big long list of solutions. So that anytime you got a trig function in an equation and you're using the solve command, you better restrict that domain. Otherwise, you could get a bunch of garbage. Okay, let's jump back over here and see what we got next. Okay, it says solve an equation graphically, that is find intersections of graphs. So we're going to solve the 2 equations above graphically. So I'm going to go back to this equation and this one, but I'm going to solve them graphically instead of the solve command. I'll tell you why it's important to be able to do that later. So let's jump over to the graphing page. I'm going to add a graphing page. Okay, so the first equation I need to solve is f of x is equal to sine x. So let's graph f of x. There she is. And then let's graph sine x. Boom. And I need to identify those intersections, right? So the first thing I might want to do is kind of zoom in a little bit here. Menu, analyze graph, intersection. So I'd like to find that intersection, this intersection, and this intersection here. So I found all three intersections, and I know what you're thinking. Mr. Vass, this right here does not meet our acceptable precision of decimals accurate to 3 places. It doesn't, right? So let me show you something here. Number 8 says change the precision of decimal values on a graph. So what I'm going to do is I'm going to hover over the text. I'm going to hover over it, and then I'm going to hit the plus key. I just hit the plus key, I got more decimals. I'm going to hit it again. I get more decimals. Hit it again, I get more. Whoa, that's too many. Let's scale it back. I'm going to hit the minus key, right? So on a graphing page, if you need to see more decimals, hover your cursor over the text. Don't select it. Hover and then hit the plus or minus key. That is, listen, go home and tell your family and friends all about this, because that's one of the least known features of the TI Nspire CAS calculator. Here, I'm going to hover over that 3.37. I'm going to hit the plus key to get more decimals so that I can get the solutions accurate to 3 decimal places and not get points taken off because I was using values that were rounded too much. Okay, so that's what we just did there. We solved an equation graphically by finding the intersections. I'd like to show you another way to do that. So let's go page, graphs. Okay, and this one, I'm going to solve that second equation, f of x equals tan x, and I'm only going to look on that interval from negative pi over 2 to pi over 2. Watch how I do this one. This is a throwback to algebra. So we got to do f of x minus tan x such that x is between negative pi over 2 and pi over 2. We're going to go ahead and grip it and rip it. Boom. There's our graph. Okay, let's zoom in here a little bit. Okay, so I graphed f of x minus tan x. We need to find out when f of x equals tan x. That's going to be this 0 right here. Menu, analyze graph. Would you look at that? The first option is find the 0. 0.159er. Okay, 0.159er. Let's expand that a few more decimals. Correct answer would be 0.158 or 0.159 because you know you're allowed to truncate or round. Okay, so let's jump back over here. We've done number 7 and number 8. Question 9, find the zeros of f of x graphically. I'll do that even though I kind of just showed you how to do that with f of x equals tan x. So let's just add another page here. Graphs page. We're going to graph f of x again. There's our good friend f of x. We want to find those zeros. Menu. Analyze graph. Come on, analyze graph. 0. So let's see what happens if I... Okay, so now these things are all kind of sitting over top of each other. If I grab a hold of this text here, I can move it, and notice how if you click this, if you grab it and click the middle button in your click pad, okay, that will move the text, but you have to see the little hand close to do that, right? And then let's move this one here, and then this one here, and again, those aren't accurate to 3 decimals, so if I need those zeros, I better click out and take a look at some more precision than what I see there. So hover and hit the plus key. Okay, so let's jump back to this list of things. We've done 1 through 9, and that was all pretty easy. I mean, that hasn't taken too long. Now, warning, look at number 10. I'm given this crazy function, and then I have to find k between 1 and 4 such that g of k is equal to 9.8757. You'll notice that this is a 4-pepper problem. It was on the 2021 AP Calculus exam. It was FRQ number 1, Part D. The reason it's a 4-pepper problem is because students tried to use the solve command, and the solve command failed. The solve command turned their calculator into a paperweight, and they just got the little spinning symbol. They had to reboot their calculator if they knew that was a problem, and this really was a problem for students, this question. So why do I encourage you to be able to find solutions graphically in these last couple problems? It's because of things like this. So let's see how we would do this on our calculator. I'm going to go ahead and just start a new page so that I have all of that old stuff cleared out of memory. I'm going to go ahead and enter that function g in memory just so I have it. So g of r is 2 minus 16 times cosine of 1.57 times the square root of r, and then that whole cosine function I need to cube. Grip it and rip it. Boom, stored to memory. Okay, so now I need to see when that function is equal to 9.87579. Let's go over to a graphing page, add a graph. First thing I'm going to do is graph g of r. Okay, so graph g of r, I grip it and rip it, and uh-oh, what problem did I just create? You pause the video and answer the question. What problem did I just create? The problem that I just created is your calculator is graphing in terms of x, not r. So even though I entered it as g of r over here on page 1.1, it's got to be g of x here. Ah, there it is. Look, that was an easy fix. Okay, that was an easy fix. Now, we're only interested on looking for solutions from 1 to 4. Okay, so what I'd really like to do here is jump back up and say, let's just graph this from 1 to 4. Grip it and rip it. There we go. We got this graph from 1 to 4. Let's just kind of pull this down a little bit. Oh, that's a nice graph. Okay, so now I need to see what value of k makes g of r equal to 9.87579. So let's graph a horizontal line at 9.87579. Double check to make sure I typed that in right. Looks good. Grip it and rip it. Boom. So if you had used the solve command on this question in 2021, your calculator would have turned into a paperweight. Now, if I think about it graphically, all I got to do is find the intersection of those graphs. So menu, analyze graph, find the intersections, boom, boom. There's my answer. Uh-oh, better show more than just one decimal place there. 2.497, final answer. Folks, that's it for the video. I hope you watch this video because it will help you in Chapter 3 and beyond.